Hello and welcome to How to Do That. Today we are doing tutorial 1.5, which is not in your Arduino Starter Kit project book. I have to confess I've already recorded tutorial number 2, but I always let somebody that doesn't know much about electronics view the video, and they said that they felt very overwhelmed by the code used in the tutorial. Now the code is not particularly complicated, but if you've never programmed before, I can definitely see how it is a bit overwhelming. It introduces a lot of concepts, plus with the wiring as well, it's not clear what's a circuit, what's not a circuit. So I just thought it would be good to actually do my own tutorial in between tutorial 1 and 2 in the Arduino project book. That is a much more simplified example, and I will actually be able to explain in a lot more detail and with a lot more clarity what these new concepts mean. Now, we will be viewing code that I've written. It's only a few lines long, it's not very long at all. But if after this tutorial you would still like more information, maybe an actual printed version, I will be uploading all my code with comments, and it is a lot of comments that will actually teach you everything there is to know about the program that we're going to be doing today. I will be uploading that, and I will be putting the link down in the description below. But for now, let's get started. Let's learn together. So the link is a Patreon link. The upload is completely free though, and things like this will always be free. Patreon, hopefully one day I will have enough content to justify even having it, but I wanted to go ahead and reserve the name. But I figured it would be a good place to upload things like this. But like I said, things like this will always be free. Patreon will just be a way to support the channel if you're able to later on, but it's not going to be a thing that you have to do if you want to learn, X, Y, or Z. So the first thing we're going to do is we're going to wire up a circuit. And I want to start out by telling you the purpose of the circuit. We want to have a push button switch that when you press it will allow a signal to be received by one of these pins in your Arduino board. That signal that's going to be received by one of these pins will then be read by the program that we're going to install in this chip right here. Whenever you're programming an Arduino and uploading a script or a sketch, which is what they like to call it, whenever you're uploading a sketch, this is where it's going, into this chip right here. Once we get a signal from pushing this button, we are going to have an LED on a completely separate circuit and plugged into a different pin on the board that the program that's in here will then be able to interact with and turn on and off. This result is quite similar to tutorial 01, where we had a button and an LED in series with one another that when you press the button did the same thing. It would turn the LED on, and when you release the button would turn the LED off. However, by breaking this up into 2 different circuits, with the button having one circuit and the LED that we'll be putting up here having a separate circuit, we can actually do more than just turn something on or off. In fact, we are going to make the LED blink when we press the button, and when we let go of the button, the LED will just stay on. Both of these behaviors are very different than what we saw in the last tutorial, and I think will drive home the point better about how you can form circuits with an Arduino board in a simplified setup. We will then go to the computer and actually see how to program this behavior in, and you'll see that it's actually not that complex. But again, if you want more information, I have typed up a lot of comments on the code that we're going to be looking at today that will be available for download in the description below. So to get started, I'm first going to make the button assembly, the push button switch assembly. So I'm just going to place it down here, pretty much wherever I feel like. As just a little tip here, I do like to place my components to where their legs are going to be right across from one of these groupings here, where my power is going to be coming from. That's just to keep things a bit less complicated. You can do it however you want. That's just how I generally do it. Now, I think I do go into this in my tutorial 02 video, so I'm sorry that I've already filmed that one and I'm releasing this one beforehand. But do keep in mind that the legs coming out of the switch need to be on the side that we're going to be wiring up things to. Because remember, this is an open circuit that requires a push of the button in order to close. Whereas if you did it this way, this is already a closed circuit. That means the button doesn't matter. Whatever you wire on the other side of this is going to be automatically powered. We don't want that. We want to be able to interact with the switch to do things, so we want this side of the switch to be pointed in this direction. Next, I'm going to go ahead and connect up the power to this button. So to get power to this button, we don't have to do anything fancy. We're just going to do what we've always done, and that is place a wire between the positive terminal and the row connecting to the leg of the switch. There we go. Positive to the row with the leg on the switch. So next, to complete the circuit, we want the button to go to ground. Now, I know it seems like it's not much of a circuit yet, but bear with me, it's going to make sense. For this button, we are going to need a 10 kilo ohm resistor. You can consult page 41 in your starter kit for a picture of what one of these looks like. And if you would rather actually try and read the colored bands, you can also use what is on page 41, or you can view the resistor color codes video on this channel. Resistors, unlike LEDs, it doesn't matter which direction that you put them in. I don't know if I ever said that. It doesn't matter if the positive is hooked up to this side or if it's hooked up to this side. It's all going to go through the resistor just fine. So it doesn't matter which direction you hook these up in. So for this, I'm going to use this resistor to connect the bottom leg of the switch to the negative or ground terminal. And as always, I'm making sure it is fully seated down. Okay, so now we have a circuit that, if we had our typical lines running out of here and this was powered, you'd have a button that's an open circuit and you press it, now it's a closed circuit. But it doesn't do anything. And there's currently no way that we can figure out if the button is pressed or not. This board has no way of knowing if we've pressed the button or not. So what can we do about that? Well, that is the purpose of these pins here. In code, we're going to make one of these an input pin, and I'm just going to go ahead and give you a spoiler. It's pin number 2. We're going to make pin number 2 an input pin that will actually take an electrical signal from this end of the switch. It's the negative side of the switch. It's going to take a signal from there. It's going to know if the switch is open, there's not going to be a voltage. If the switch is closed or pressed, there will be a voltage to detect here. And we will receive that through the board here, and then we will have some programming logic that will decide what to do with that information. So let's do that now. We're going to wire up this leg of the switch. So then I'm just going to kind of pull that around, and I'm doing it like so, just so you can really better see things. So this is pin number 2 and it's labeled right here. So now we have positive, goes across this green wire into the switch, across this leg if the switch were closed, and then through here, and then you have a resistor going to ground, and you have this wire that is receiving if there is a voltage there or not. If there's not a voltage, it'll be a low signal or off. If there is a voltage, it will be a high signal or on, 5 volts. So now we have our button circuit. This is a complete circuit. It is completely standalone. It is powered by this column in the breadboard, and it will have nothing to do with the circuit that we are going to be making for the LED. And that is a very important point, because by having separate circuits, we can control them with what we program in this chip. So that's the name of the game here, is creating a lot of separate circuits that we can do things with. So let's make that LED circuit now. So to begin, I'm going to place my LED, and the long side goes toward the positive side of your circuit. And by the way, I always do positive up toward the top. You don't actually have to. You could do positive toward the bottom. Just make sure that you are hooking up the row that the longer side of the LED is on to the positive column of your breadboard. In this case, we're actually not going to be hooking it up to the breadboard, and you'll see why here momentarily, but just know that the long side always goes to the positive voltage. Now this long side of the LED also has a name, and that name is an anode, and the short side is called a cathode. So I'm going to put the anode up toward the top of my board. Next thing we're going to do is, just like down here, we have a resistor. We need another resistor for the LED, because again, this is a separate circuit. For this, we're going to use a 220 ohm resistor. This is the same resistor type that we used in the last tutorial, I believe. Again, you can look on page 41 or look at the resistor color codes video on this channel for how to identify these. I am, just like we did down here, going to connect the negative or cathode to the negative column of the breadboard, which is our ground. And by ground, I do mean 0 volts, because again, we need to go from a higher voltage to a lower voltage. Now, I've already kind of ruined the surprise a little bit, but you would think that you want to plug in the anode to the positive column here. But if we did that, we would have the same issue as we did down here. The board would have no way of interacting with this LED. And in this case, we actually don't care about monitoring the LED. In this case, we want to control the LED. So just having a simple wire go to what we're going to define as an input pin is not enough. We need an output pin. And what an output pin does is it either gives low or 0 off voltage, or it gives high or on 5 volts. Notice what I said there, it will give a voltage. That sounds a lot like the positive column of this breadboard whenever we plug it in, right? Well, that's because that's exactly what's going to happen here. We're going to connect a pin from here into the positive side of our LED here. And that pin we will control with the program inside of this chip, and we will turn it on or off to our liking of what we want the LED to do when the button is either pressed or not pressed. So again, that's the reason why we have a separate circuit here, and now we're going to have a separate circuit here. So I'm going to choose pin 7 to be that. It really doesn't matter what pins you choose. Just make sure you don't choose pin 0 or 1. Those are used for different things. As far as I know, you don't really want to choose them. Again, we're learning together here. But don't choose pin 0 or 1 for anything. And there's also a ground pin, and there's some other pins up above here. Just pick any that is labeled between 2 and 13, and you should be just fine. In my case, I wanted to pick pin 7. So let me go ahead and hook up this side of the LED to pin number 7. Sorry if this looks a bit messy. I'm trying to do it in a way to where you understand where all the wires are going. So you may be wondering why, just like in the first tutorial, we connect this circuit here to the positive column, but we don't connect this circuit here to the positive column. And the reason is because we're going to make this pin here, pin number 7, an output pin. And what an output pin means is that we can supply a voltage to this pin, or we cannot supply a voltage. So it's on or off. That's the whole basis of digital logic, really. Now, if we're able to turn a voltage on or off this pin, we actually don't need to plug this circuit in to the positive here, because we're going to supply that through this pin. Why would we want to do that? Well, the reason is because we're going to be programming in logic into our chip here, and that logic is what's going to decide when this voltage gets turned on and off. We can't do that if this was plugged into the positive here on the breadboard, because there'd be no way of us interacting with this circuit. So in order for us to interact with the circuit and tell it when to be powered or not, we just supply the power through the pin itself, and we will be programming that in our program that we will be writing. Now, when I say output, I mean output in relation to this board. So all the terms that we're going to be using are as if you were inside this chip here, and what are you going to experience? If I'm going to be outputting a voltage away from me, so I'm here, if I'm going to be outputting a voltage into something else, that's an output for me. Likewise, if I'm going to be reading or taking in information, like I am here, that's going to be an input into me. So at this point, the wiring is done. We have a complete circuit here. We're going to have power being supplied from here, going into the LED, out through the resistor and into the negative or ground. And likewise, we have power coming straight from the breadboard to the button that, if it is pressed, will then go out through the legs, through the resistor, and we will also be detecting what the voltage is with this wire here. So now we can move on to the programming of this chip in order to control what this LED does, whether the button is not pressed or pressed. So to get started in the code, we want to open up our Arduino IDE, which again stands for Integrated Development Environment. If you have not set this up, I do have a video on how to make sure everything is set up and also how to ensure that your board is connected here and able to be used. When the Arduino IDE first starts up, you will see this type of window here. Now I've actually made my font size larger, and if you would also like yours larger, all you have to do is go to Preferences up in the menu up top here, and I changed my font size to 24 and I hit OK. This is the sketch window. The sketch window is what the Arduino calls its scripts or program. And this sketch here is your most basic sketch, which has these two functions here, setup and loop. You will need these functions for every Arduino program that you make. And it's just by convenience that they put them here for you to use. Let's talk about what these do for a second before we actually get to programming. So the setup function is run one time the moment that your program is either uploaded or when it is reset or first powered on. So, the idea here is eventually your electronics exist in the outside world somewhere, and so they'll be powered with some external source, they'll have an on-off switch. This setup block will be run every time that your electronics are turned on, but it will only run that one time. It will not run again until you turn off the Arduino and turn it back on, or in our case, when we upload a new sketch, because that actually does perform a reset onto the chip. However, that doesn't really help us actually do things in the real world. Like, we don't want to have to turn something on the moment we want to use it and have it just perform a function one time. So if we want something to run continuously, whether it's checking for something or performing some other function, we'll want to use the loop function. So the loop function will run continuously. It will run immediately after setup, and it will keep running, executing all code within these curly braces here. It will keep running from top to bottom, top to bottom, top to bottom. It will just keep repeating things over and over and over. And this is where we're going to program basically all of the logic to make our circuit do what we're wanting it to do. So let's get started with the setup. Now, the first thing I'm going to do is I'm probably just going to erase this right here. This is what's called a comment. And if it's a comment, because number one, it's written like, in plain English. But number two, it has these 2 forward slashes here. And anytime that you type 2 forward slashes, you can type anything you want and the program will not run it. So anything that you put in the same line as 2 forward slashes is just for your benefit or someone else's benefit if they're reading your code. It's just a way for you to maybe explain what you're about to do in code. If something is a little bit confusing, you can kind of write it out. That way, if you're coming back and looking at it months from now, you'll know what your code is doing. I'm just going to erase these. I don't need them for right now, so I'm just gonna erase that to clean up my code a little bit. Now, when I did that, notice that my cursor is back here at the beginning of the line. And you want to kind of watch for this as you're programming. You want to use proper code indentation. So notice here that there's 1, 2 spaces next to this comment here. And in fact, if I were to hit enter on the end of this line, it stays at that indentation level. And the reason being is that really helps organize the code visually. I'm actually not sure if Arduino requires that spacing to be there, but trust me, you want it there regardless, because whenever we start getting into nested functions, which are basically functions within a function or statements within a function, you're gonna want the indentions there. That way you can visually see how your code is flowing. Up here, it didn't give that to me. All I have to do is hit tab and I'm there. So even though it's actually 1, 2 spaces, if I just hit tab, it tabs me over in the proper increments. So always be mindful of that, and that will make sense as we go along programming. I just wanted to bring it up now so you are aware of it. Now for setup, we're just going to be programming what needs to be said one time. And there's been a lot of talk about inputs and outputs, right? So we're gonna have an input wire coming from the button circuit. That's what's going to allow us to read in if the button is on or off. And then we're also going to have an output pin, which is pin number 7, and that's what's going to control our LED. Let's go ahead and tell the Arduino that that's our intention for those 2 pins. To do that, we need to set the mode of the pin if it's input or output. And to do that, there is an internal function called pin mode that is case sensitive. Notice how it turned orange the moment that I typed it in correctly. If I didn't type the M as capital, it doesn't work. So that's a way that you can kind of check yourself if you're typing in the correct thing. So pin mode, like I said, is an internal function. Now you can find a list of these on the Arduino website in their documentation of all the different functions that are there for you to use. You will find though that will be very overwhelming. Generally, documentation like that is good just to use if you've seen a function used elsewhere and then you want to look it up for more information. It's really difficult to try and browse documentation like that. You can do it, but it is a little bit overwhelming. So I would recommend instead looking at other people's code and see how they did things. And if there's a function that you don't understand that they used, look that up. That way you now see how that function is used in context. Functions have parentheses like this that come after them because inside of these parentheses, we are going to define its arguments. An argument is just something that a function needs in order to do its job. So we need to supply it some type of information. So what pin mode expects is 2 arguments. One is the pin number. We'll do pin number 2 first. And the second argument, separated by a comma, is if it is input or output. In this case, it is an input, as we've already explained. And every line, unless it ends in one of these braces or if it's a comment or something, every line needs to end in a semicolon. Do not forget that. Nothing's gonna go bad or anything on the board. It's just your program won't run. You might get a little bit aggravated trying to figure out why it's not running. It is so easy to forget to put semicolons on the end. And the only purpose of the semicolon is because it tells the Arduino, hey, this line of code is terminating. I need to go ahead and execute that line before moving on to the next one. So next we're going to define the output pin, which as we've already discussed is pin number 7, and that is an output. So before we move on, I do want to mention about us declaring this as an input. You will find online kind of a divide of people that some say you should declare it as an input and some say you shouldn't, and here's why. The moment you turn on the Arduino and it boosts itself up and it's now ready to execute whatever program that you've given, it defines automatically all the pins as inputs, which means we could actually delete that line and the program would still work just the same. We could still use pin 2 later to read in the value, but it's already set as an input automatically. The reason that I personally recommend that you have that line is because, again, it really helps you understand your own code, either while you're debugging it or writing it, or if you come back to it months from now, you will be able to see, oh, these pins are supposed to be input pins, they're supposed to be output pins. Instead of trying to search through your code and figure out based on context, oh, these are supposed to be inputs. So I highly recommend to declare not just your outputs, but also your inputs. We are actually done with the setup now. So now we can go down to the loop function. The first thing we need to do is we need to figure out is the button pressed or is it not pressed? We've already put a wire on the button into pin 2 that is going to be reading the button. It's going to be intercepting the signal of the button if it's on or off. But it's not just good enough to have the wire connected to the pin. And yes, we've declared it as an input, but what we actually need is to read the value. So that's the first thing we're going to do, is we're going to create a place in memory to store if the button is currently pressed or not pressed. And then we're going to read that value from pin 2 to then know if it's pressed or not pressed. Now, for digital logic, things can only be off or 0, also known as low, or they can be on or 1, also known as high. You will find that we will interchangeably either use the integer or low or high. They mean the exact same thing. What we're going to do is we're going to first create that place in memory that we were talking about earlier. And that is what is going to be called a variable. A variable is a reserved spot in the Arduino's memory that can store a value that will change over time. Now, we have to be the ones to change it. Now, to start out writing a variable, you need to tell the machine what type of variable is it going to be. We've actually already said what type it's going to be. I said it's going to be either a 0 or a 1, which is an integer. An integer, int means integer. It just tells the Arduino this is going to be an integer that's stored in this variable. Now, the next thing it expects is what is the name of the variable going to be? And this can be anything within reason. You don't want to be using special characters or anything like that, but you want it to be something short and yet descriptive to where at a glance throughout your code, you will understand what the variable is being used for. In this case, since this is input from the switch, we're going to store what state the switch is in, whether it's going to be on or off. We're going to store that switch state in a variable called switch state. It's very good to have these short descriptive variables in your code. Now, what is that going to equal? Well, we're just going to go ahead and initialize the variable. We're just going to set a number to it. I'm just going to assume that the switch starts off in the off state, or 0. And as always, I'm going to end with a semicolon. Now, this doesn't do us much good though, right? Because now our program is just always assuming that the switch is not going to be pressed. We haven't read in the value from pin 2 yet. Yes, we defined it as an input, but we haven't looked at the input yet. We haven't looked at what's coming in. We haven't read that value. So to do that, we're going to go down to the next line and we're going to say switch state, which is the variable we just created. We're going to set that equal to, and here's going to be another internal function, I'll explain it shortly, DigitalRead, make sure the capital R is there, and I'm going to tell it which pin I want it to read, and that is pin number 2, close parenthesis and semicolon. DigitalRead will read a digital input from a pin. This is another one of those internal functions, so we don't have to define what DigitalRead meant before we used it. You now know, is the button pressed or is it not pressed? And that value is now stored inside of switch state. So now we've read in the value from the pin. This is going to return either a 0 or a 1, which is what we expect. It's going to be either off or on. Now that we have that information though, we need to do something with that information. And so to do that, we're going to use what's called an if statement. And an if statement is really just a way to logically decide upon a course of action. To begin an if statement, you just start typing the word if, space, open parenthesis, and then we want to type some type of condition. What a condition is really just a comparison. So we're going to compare values by either asking the question, hey, is this value equal to this other value, or is it less than another value? Is it greater than another value? Is it just not equal to a different value? Whatever it may be, you can put that condition here, and then if it's true, it will execute the code within it. So let's go ahead and do one now. So the first thing I want to do is I want to ask, hey, is my switch state equal to low, which means the button is not pressed? Notice that I used 2 equal signs here, and the reason is because a single equal sign sets a variable value. So I am setting switch state to equal the value returned from DigitalRead. But in this case, I don't want to set switch state equal to low. I want to know if it is low. So the way you do that is by just using 2 equal signs in order to ask, hey, compare this to this. If they equal, then that means it's true. So that would mean before anybody's pressed the button, before anybody's closed that switch, this will equal true. And because that equals true, anything that we type in these curly braces here will be executed. So it will actually be performed on the board. Now notice that after I topped that open curly brace and hit enter, it automatically tabbed me over a little bit more and put the closing curly brace in. That's one of the good things about using an IDE. Not only does it color your function names for you for better readability, but it also helps you type out your code to where it's better organized. So I get to decide what to do when the button isn't pressed. And I've decided that I actually want the LED to just stay on if the button is not pressed. Just because that's kind of odd, isn't it? Like you would think if you press the button, then the light turns on. But I want to have it to where when the button is not pressed, the light turns on. So how do we do that? Well, we're going to use a function similar to the DigitalRead function, but where read is for input, write is for output. So I'm going to type DigitalWrite, and I'm going to give it 2 arguments here. It expects 2 arguments. The first is the pin number that I want to write a value to, which in this case is 7, and I want that to be on. And we already talked about what on meant. Either means a 1 or high. High will simply supply a voltage to that pin, and of course end in my semicolon. So if we were to run this right now, we would actually see that the light would just stay on. So let's actually do that now. So before I plug my computer into this, I'm going to go ahead and hook up my pins, black to ground and to negative, and red to 5V, which is 5 volts, and into the positive. And now I can hook in my computer. Okay, so I'm going to, now that my board is plugged in, I'm going to come up here and hit the upload button. And you'll see it do some things down here. So you'll notice that I got an error down here. Now, I'm actually really glad that this came up because I get to show you how to fix it. It says an error occurred while uploading the sketch. Can't open device, blah, 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 no such file or directory. What that typically means is if you go up here to Tools, the Tools menu, it either means the board is not selected, which Arduino Uno is the correct board, or it means the port is not selected, and that's actually the issue here. So I'm going to select the correct port, and if you need more advice on how to do that, if yours doesn't have, in plain English here, Arduino Uno is connected here. If you need more help in that, please see the initial setup video also on this channel that takes you through some troubleshooting for that. So I'm gonna click on that port, and now if I hit upload, okay, it's gonna ask me to save, so let me do that now. And you see down here, it said uploading, and now done uploading. So there's no errors, everything looks good to go. So now if we go back to our board, we see the light is on and the button is not pressed. What do you think happens if I press the button? Because we said that the button has to not be pressed in order for this to turn on. So what do you think happens? Ooh, nothing. Why do you think that is? Well, it's because we haven't supplied it any logic yet for what to do if this state changes. All we said is if the button is not pressed to turn this on, but we don't say to turn it off or do anything else if the button is pressed. So it just keeps the state of when the button wasn't pressed and just keeps it for when it is, because we haven't told it anything otherwise. But let's fix that. Let's make it do something else. So back to our code here. We have this if statement, but there's a way we can extend the if statement to say, if this is no longer true, do something else. And that is else. So I'm gonna return down to to the next line on that curly brace. I'm gonna say else, and now another open brace, enter. And see, it tabs us back over again correctly. So here's where we can do something interesting if the button is pressed. And I wanna make it blink. So how can we make something blink? What is blinking? Well, it's just something turning off and on, with a little bit of delay in between each. We want it to stay off for a bit and then stay on for a bit, and just keep doing that. So we've already learned the internal function for how to write a value to change the voltage being given to pin 7. So let's do that again. Let's, this time, instead of turning on the voltage, let's turn it off. And if we want to go ahead and test that, we can now. So let's upload that. And now let's look over here at our circuit. The button is not pressed. The switch state is therefore 0, so our light's on. But if we press the button, the switch state should become 1, because again, that code is looping. Every time that it gets to the bottom of the code, it just loops back again, over and over and over. So every time it loops, we're rereading this value here into pin 2. So if we press the button now, the light turns off. It's kind of weird, isn't it? You would think it'd be the other way around, you know? The button is not pressed, you think the light should be off, but when you press the button, the light turns off. And that's one of the beauties of microprocessors and being able to program when pins do certain things. You can really create pretty much anything that you desire by just doing a little bit of code in these chips. But we want this to blink when we press and hold the button. So let's do that now. Like I said, to have something blink, you want it to turn off, stay that way for a bit, then turn it on and stay that way for a bit longer. How do we do that? Well, there's another internal function called delay, and it does exactly what you think. It delays executing further code for a certain period of time. Now, delay only expects one argument, and that argument is written in milliseconds. There are 1,000 milliseconds to 1 second. If I want the delay to be for a quarter second, I will want the value in here to be 250 milliseconds. 250 out of 1,000 milliseconds is a quarter of a second. Next, I'm going to do another digital write, still on pin 7, but now I want to change it to high. So now I'm powering it again. Now, if I were to run the code just like this, and I press the button, it's going to come down here and it's going to turn the LED off, and it's going to remain that way for a quarter second, and then it's going to turn the LED on. But remember, this is a computer and works really, really fast. It's now at the bottom of the code. I didn't put another delay on here. So it's going to immediately go to the bottom and then go right back to the top and execute code again. It's going to go to this if statement. It's going to find, oh, the button's pressed, so do the else statement instead, and it's going to immediately turn the LED back off. You're barely going to be able to see the LED turn on, if at all, because we didn't keep this as high for very long. So all we got to do is put another delay right after it. And you want to kind of think of what your code's going to do as you're writing it, because it will just save you a lot of headache in the future if you just kind of logically think of what's going to be going on, what it's going to look like. So let's run this and see what it does. Okay, we are done uploading. And now we're back at our circuit here. We see the switch has a state of 0 because I'm not pressing it. So the LED is on. But now if I press and hold the button down, we get blinking. How cool is that? So we were able to do that with just a little bit of logic. And now if I release the button, it stays on, which is exactly what we would expect. Now, looking back at the code, I actually made a decision here. I could have just as easily turned on the pin here. I could have given this a high value instead of a low value. So why don't I do that and then make this high value a low value? It should still blink, right? Well, let's upload this and see what it does. So we're back over here with our circuit, and I will give you a little bit of a spoiler. It is going to blink, but watch how long it takes once I press the button and press. Did you see that little bit of delay? It's not a big deal in something like this, but depending on your use case, your end user of whatever electronics you're programming, you may not want a delay. You may want a very immediate tactile response from your electronics. And so since the light is already on, if my code to start out when I press the button, it's just going to stay on for a moment, that might make me think, oh, my button's not responding. Right now it's only a quarter second, but what if it takes 2 seconds? I might press and hold that button and be like, oh, nothing's working. You want to have as clean of an experience as possible whenever you're programming or wiring things up. And so always keep in mind the end user in anything that you do. So I'm gonna go ahead and change this back to how it was. Now, there's one other thing that we could do with the code, and that's actually up here where we defined this variable. Now, when you're programming on a computer, modern day computer, you basically have infinite amounts of memory to do things with. When you're programming an Arduino board, there is not that much memory to go around. Memory is actually very precious on these boards. Every time that we loop here, we are recreating this variable, which means it's gonna have to remove this variable from memory if it has a garbage collection, or it's going to just keep creating another instance in memory somewhere for this variable. So we're just taking up memory needlessly every loop. And right now, you're not going to notice any issues, but what if this is a board that's meant to run for weeks and weeks without restart? You want to have as efficient of memory as possible. So right now, this variable is what's called a local variable because it only exists locally because it is defined within this function. But we can instead make it what's called a global variable. It can be used anywhere in your code, only have to be defined once, so you get to avoid those memory issues. So the way we're going to do that is we're just going to highlight this line here, and then you can either right click and hit cut. Then I'm going to go all the way up to the top, space down a couple lines, and I'm going to paste back in that line. The reason it's now a global variable is that it exists outside of these functions, and we're going to declare it at the main beginning. That way anything below it is able to use it. Anytime that you have, say, int and then a name, this can also be other variable types that we'll get into in future tutorials, but anytime you have something like this, you are declaring what a variable is, and that is taking up memory every time that you do that. So you don't want those to be inside of, say, the loop function. Now, I have another question for you. I said that this is a one-time thing. Well, why didn't I put that in the setup function? Isn't that 4 one-time things that I declare? Well, if this line were in the setup function, remember what I said earlier. If it's inside of a function, it's called a local variable because it is only allowed to be used in that function. So the moment that we exit outside of setup, this variable no longer exists. So if we were to run it like this, it wouldn't work. And in fact, when you try to upload a program like this, it actually gives you an error. It says switch state was not declared in this scope. And the scope is what I'm calling the local variable or global variable. So it's saying, hey, in this loop here, this loop function, we've never heard of something called switch state. So we're going to throw an error. However, if we go back to how it was, with switch state now as a global variable and we try to upload, we see that we get no errors because switch state is defined for everything in this sketch here because it exists outside of these functions. This code is now complete, but maybe we want to comment some lines here so we know what things are used for in the future if we're ever coming back to our code. So maybe I want to say, hey, pin number 7 is supposed to be an LED. So all I have to do, I'm just gonna do a couple spaces over from my semicolon here just for readability. I'm gonna put those forward slashes on. This is an LED. The program, as soon as it sees these 2 forward slashes, is going to ignore everything that comes after it. What if I want a really long comment? So all you have to do is you hit / asterisk, enter. See, your IDE will automatically know that you want a multi-line comment. It makes all these other little symbols for you. When you type something and then you hit enter, notice that it just made a little asterisk for me, has me tabbed over to the correct place, and I can type whatever I want. So that is how you make a multi-line comment. You can't put a multi-line comment beside of a variable, or rather you can, it's just bad practice too, things look a little bit messy. So that is going to do it for tutorial 1.5. We now have a working circuit, does everything that we think it should. Hopefully this made sense and will help you better understand tutorial 2 coming up. The reason I made this tutorial again is just because there seemed to be a big leap between tutorial 1 and 2 in the Arduino starter kit book. So hopefully this will give you a lot more of a primer to what a microcontroller is and will allow you to better ease into tutorial number 2. So again, I do hope that you found this tutorial helpful. If this video helped you, or if you have any suggestions for how I can make these videos better for your learning, please comment down below. If you have any questions, please comment below and I will do my best to assist you. And if it's a common question, I may make a video on it. If you like this content, please hit the thumbs up button on this video and subscribe and hit the bell icon for new video releases. It's free and it really does help out the channel. Till next time, see ya.